Everybody, welcome back. We're going to continue on with talking about different properties of data today. We're going to now expand into something called interval data and also ratio data. Okay, so last time and the time before, we covered how all variables that exist, all things that can vary, must have values they can take on, and those values have to be able to distinguish from one another. Otherwise, what are we even talking about, okay? If I say something is solid and something is liquid, that has to mean two different things, okay? The states of matter. State of matter might be a variable, right? And the state of matter labels or values that they can take on have to mean something different. Okay, that at a bare minimum is categorical. In other words, it allows us to distinguish among these different values that they can take on. And so a purely categorical variable could have two values. At a bare minimum, it has to have at least two values. It could have 50. For example, what state do you live in right now? If I asked a whole bunch of people that, assuming U.S. residents, obviously, that could be 50 different values, but they all distinguish from each other. And again, there's no inherent order to those necessarily, right? So this is all very important. Now, if you do have inherent order to the data, that is called ordinal data, or it's got ordinal properties. It is a variable with ordinal properties, right? And so there are lots of instances of that where there's some inherent clear order to it that is obvious to everyone, or it should be relatively obvious because we've decided it's that way. For example, as we talked about the Olympic medal system that we talked about last time. Okay, now today we're going to move deeper into this kind of thing. So we'll start with an example of kind of where the need for these other properties are, or why these other properties exist. So let's just start with this little example. Let's say that I tell you my 5 favorite movies in order. Okay, so this is going to be ordinal data by definition. And I haven't actually thought this through very carefully, so don't critique me on this, but these are very good movies. I'll give you that. But so anyway, let's just imagine that I were to say, yeah, my 5 favorite movies are in order: Casino Royale, It, Awakenings, Amadeus, and Joker. Now, what's interesting here is I do tell you the order in which I have my favorite movies, okay? Because you would say, wow, you like Casino Royale the most of all. And I would say, yeah, that's right. And you liked Awakenings more than you liked Amadeus, for example. And I would say, yes, right, something like that. And you would know this is true because I've given you the order of my 5 favorite movies. However, what this does not tell you is how much more did I like, for example, Amadeus compared to Joker. It doesn't tell you any distance between those values. You could say, okay, so you liked Awakenings 2 times more than you like Joker. Even that phrasing's not quite right though, because it's like it has 2 place values above Joker. But that doesn't tell me how much more, it doesn't tell you how much more I liked it compared. Like to do that, you would need some other kind of scale, right? You would say on a scale of 0 to 10, for example, how much did you like each of these movies? And now I could give you something like that. That scale of 0 to 10, the star system, for example, that is used by some websites like IMDb, has different properties than simply this ranking system. So we'll talk about that now, what that is. That kind of system is called interval data. In other words, it is data with interval properties. Okay, so we'll look at something like that. So let's say then that I tell you I am 3 inches taller than my youngest brother, and that's actually true. I'm 3 inches taller than my youngest brother. That tells you not only am I taller, okay, that's ordinal, but it also tells you how much taller I am. If it does that, the scale you're using, the variable you're using, in this case height in inches, has what's called interval properties. So interval properties has equal intervals between each of the values that the variable can take on. Inches, for example, is the variable, and each of the values it can take on are the numbers, right? 1 inch, 2 inch, 3 inch, 4 inch, and then you can have decimal places of those inches. That's fine. But that tells you something, right? The 1 inch, for example, tells you that it is 1 inch smaller than 2 inches. And things like that. I can tell you 6 inches comes after 2 inches. There's the inherent order. It has ordinal properties. But also I can tell you that it's got equal intervals among each of its values it can take on. For example, that also tells you that the difference between 10 and 15 inches is the same difference as between 95 and 100 inches. It's a 5-inch difference, right? Okay, so those are interval data. Now, a lot of data we have are purely ordinal and it just doesn't have interval properties to it. For example, the ranking system, like I said. Some data have beyond interval properties as well. I haven't talked about what that is yet. And then some data are pure IQ measures. So before I start, are purely interval data, such as IQ. IQ as a variable is purely interval data. So I'll talk about that in just a moment. First, I want to make the point here that every variable you can find that has interval properties to it must also have the other properties we've talked about. In other words, if you have an interval variable, a variable that has interval data, equal intervals among its values, then it must also be ordinal. It would be impossible. It wouldn't make any sense to treat something as if it were ordinal if it didn't also have ordinal properties. And the same thing is true, obviously, of the categorical data. If it can't distinguish among its values, then it's not useful. It's not even information, really. Okay, and so every variable must have at least categorical properties. Beyond that, some variables do have ordinal properties, and every variable that has ordinal properties must have categorical properties. However, every variable that has ordinal properties does not necessarily have interval properties. Okay, so there's a bit of a hierarchy. Now, by the way, there is a smaller inner circle that I'm going to talk about next after I discuss IQ a little bit more. So let's now talk about IQ and what IQ does possess in the interval properties, but what it does not have. Okay, so if you're not familiar with the measure of IQ, IQ averages at 100. So in other words, if somebody tells you, I have an IQ score of 100, you say, you're exactly average. Okay. Now, what's interesting here is IQ can't be 0, regardless of how you insult the people you don't like. It's impossible to have an IQ score of 0. All right, that just doesn't exist. You couldn't measure that. Because, and think about that. So if I were to measure somebody's intelligence, in order to do that, I would have to be able to communicate something with them, right? They have to somehow be able to tell me that they understand what I'm asking, to communicate in that way. And so to have 0 intelligence is impossible to measure. You can't measure 0 intelligence, right? I could say my lamp is not intelligent at all, right? But I'm not measuring anything on an IQ scale. Anyway, so the point here is that 0 doesn't exist, right? Because there's no such thing on the scale of IQ as 0 intelligence or an IQ score of 0, right? And so the point is 100 as an average is completely arbitrary. They just made that up. The people who made up the Wechsler just completely, that's the measure of intelligence that we usually use. They just made that up. They said, well, we'll just call average 100 for our purposes. And it works, right? That's fine. But it doesn't correspond to anything in reality. Okay. Now, that's a problem because there are some, that's not necessarily a problem, I should say, but there are some data that do correspond to real world phenomena. And so that is a special kind of case. That's something that we called ratio data, or it has ratio properties. So for example, weight, of course, has ratio properties, meaning that a 0 corresponds to something real in the world, and everybody should be able to agree upon what it corresponds to. It's something about sort of physical reality you could think about. It's based in the laws of physics that there is some corresponding unit of 0 essentially. And usually we start at 0 for ratio data. So some things can weigh nothing on Earth, right? The air around me essentially weighs nothing, right? And so that 0 corresponds to something. And then if I tell you, hey, I weigh 175 pounds or whatever, it's been a while since I've measured myself, weighed myself. Everybody knows that that's in reference to 0 as sort of as the starting point, right? Okay, so therefore, weight in pounds, or really anything, weight in pounds does have ratio properties because it has this corresponding reality to it in the laws of physics, essentially. So that's a very brief way of talking about it. So yes, ratio property simply means that there is some sort of objective reality to it. All right, let's now practice with these things. let's start with this. So do these have ratio properties, interval properties, ordinal properties, or purely categorical properties, and nothing beyond, for example? So I'll read these and then pause and think about it and then start the video again. All right, height in inches. As you can imagine, it's very much like weight in pounds, for example. Height in inches does correspond to some real phenomenon, a height of 0, right? And you can't actually measure a physical object with 0 height, but we know what we're referring to when it would be 0 height. Like, for example, if my brother and I were no different in height, we're talking about some real phenomenon there, some real physical phenomenon. Okay, so this would have ratio properties. National athlete rankings, for example, the number 2 tennis player in the world compared to the number 3 tennis player in the world. Obviously, the key word here is rankings. Anything that tells you rankings does not tell you how much better the number 3 tennis player is compared to the number 4 tennis player in the world. And so this, by definition, would be ordinal properties and nothing beyond ordinal properties. So ordinal and therefore also categorical, but ordinal and nothing beyond. Phone numbers is an interesting one because it's numerical by nature. So think about that. I think the key here is that phone numbers really don't have any order to them, right? If my phone number starts with 219 and yours starts with 312, does that mean that mine came first? Does that mean that I'm in a better area code? Nothing like that, right? There's no inherent order to it, really. The way we use phone numbers is simply to distinguish among phone numbers and how to call people, how to reach people. So I think the best argument here for phone numbers is categorical and purely categorical in nature. GRE scores, if you're not familiar with these. A GRE score is a graduate record examination, and it really corresponds to nothing. There is no 0 in the scoring exactly. So if there is no 0 score in the first place, that should be a really big hint that it can't be ratio. But it does have an average and equal intervals among the scores that you can have, and so therefore it's interval by nature. Tennis scores are an interesting one if you're familiar at all with tennis. I talked about tennis earlier. What's fascinating here is you can have a 0-0 score, right? But it doesn't have equal intervals between the scorings because it goes by 10s and then 15s, if I'm not mistaken, and then it uses words as the scoring system. And so if you're arguing those numbers, that's not exactly ratio data. In fact, I don't think you could call it interval. You could make the argument it's ordinal. Now, if you were to say, well, really what's going on is they're converting the number point system to just actual like 10 points actually just means 1 point above, right? So if you're converting it, I think you could maybe make the argument that that's ratio. But the way that the numerical system works in tennis, I don't think is any of these really, except the best argument here is ordinal. Same thing, I think you could say this of bowling scores if you're familiar with how bowling works. 0 pins means that you've knocked down 0 pins. And so in that case, there is some 0 real world physical phenomenon. But as you start to score spares or strikes, now the system changes and it does not correspond any longer to how many pins you've actually knocked down. So I think bowling scores is an interesting example of how something can seem like ratio data, but in reality it's not. In fact, it's not even interval data because the scoring system sort of multiplies what you can do here. Now, other things to think about might be like golf scores and things like that, but we'll just stop there for now on those kinds of examples for the sake of time. Okay, so to make that point again, ratio data therefore has all of the other properties. It must have all the other properties or it can't be ratio data, as I made the point with the bowling scores, for example, and also tennis scores. But for example, you can have ordinal data that doesn't have interval or ratio properties, but it must have categorical data. So is this, again, there is this sort of hierarchy that can happen. Okay. So quick summary of what we covered today. Variables that have categorical properties merely distinguish among the values and maybe nothing else. However, any variable that does do that also has categorical properties. Ordinal properties means that there's also, in addition to distinguishing among the values, it has an inherent order or ranking system to the values it can take on. Interval properties means that there are also equal distances in between all of the values that they can take on, and that's in addition to all of the other things. And then ratio data, of course, have some corresponding point in reality to the scale. The scale it's usually the 0 point actually means something in the real world. All right, that's it for now. We'll cover some more stuff soon. I'll see you then.